Then question number 6. Show that the line segment joining midpoints of the opposite sides of quadrilateral bisect each other. Here I have taken one quadrilateral ABCD. P is a midpoint of AB, Q is midpoint of BC, R is midpoint of CD, S is midpoint of AD. The line segments joining the midpoints of opposite sides. These two are opposite sides, these two midpoints I am joining. These line segments bisect each other. This PR and SQ are bisect each other. To prove this, first I am taking triangle ACD. Here S is a midpoint of AD, R is midpoint of CD. So I join these two midpoints. This line segment is parallel to third side and this line segment is half of the third side by using midpoint theorem. Next, I am taking the triangle ABC. In this, P is a midpoint of AB, Q is midpoint of BC. Join these two midpoints. This line segment PQ parallel to the third side and half of the third side. Equation 2. Here also I use the midpoint theorem. From the equation 1 and 2, both right hand side are equal. Then equate the left hand side. PQ is equal to SM. SR is parallel to AC. PQ is also parallel to AC. Then PQ and SR also parallel. Then PQ parallel to SR, PQ equals to SR. We proved. Then this PQRS is nothing but parallelogram. Now, in a parallelogram, diagonals are bisect each other. We know that. See, in this figure, this is a midpoint of AD, this is midpoint of BC in a quadrilateral. I join the opposite sides midpoint. This line segment SQ is a diagonal of this parallelogram PQRS. Similarly, P is a midpoint of AB, R is midpoint of CD. These two are opposite sides. These midpoints of opposite sides I join. This line segment PR is also one of the diagonal of this PQRS. As we know that diagonals are bisect in a parallelogram. We proved PQRS is a parallelogram. Then properties of parallelogram. Diagonals are bisect each other. Therefore, PR and QS are bisect each other. PR, QS bisect each other. This is what I need to prove. The line segment joining the midpoints of opposite sides. These two are opposite sides, this is midpoints. I join this. These two are opposite sides, these two are midpoints of opposite sides. This line segment and this line segment bisect each other. I prove this is PQRS is a parallelogram. Then this SQ and PR are the diagonals. In a parallelogram, diagonals are bisect each other. Therefore, this line segments also bisect each other. So this is what I need to prove. Then question number 7. ABC is a triangle. Right angle at C, ABC. A line through the midpoint of M of hypotenuse AB. M is a midpoint of AB. From this midpoint we are drawing one line which is parallel to BC. To this BC, from the midpoint M we are drawing one line. This line touch the AC at D. Then show that first one, D is a midpoint of AC. Second one, MD is perpendicular to AC. Third one, CM and MA is half of the AB. Let's go one by one. See, first question, D is a midpoint of AC I should prove. So I am considering triangle ABC, this triangle. M is a midpoint of this AB and this line is parallel to this. So I am using the converse theorem. Midpoint and parallel to one side, then this will bisect the third side. Therefore, M is a midpoint of AB. MD is parallel to BC. Therefore, MD bisect the AC. Therefore, D will be midpoint of AC. I use the converse of the midpoint theorem. So first question finished. Second question, MD is perpendicular to AC we should prove. Means this angle is 90 I should prove. Look here, BC and MD, these two are parallel, then this is transversal line CD. So angle C, angle D, sum is 180, co-interior angle. C already we know it is 90 degree in the question. Then D also will be 90. When D is 90 degree, then I can say MD is perpendicular to AC. Next, third one, I need to prove the CM AM is half of the AB. See students, M is a midpoint of AB. I know AM is nothing but half of AB. But this AM and CM, I need to prove these two are equal. So that I am taking these two triangles. Which one? CDM triangle and MDA triangle. In these two triangles, already we know D is a midpoint. Therefore, CD of this side, this triangle, AD side of this triangle, both are equal. And this angle D is 90 means this is also 90. So, in these two triangles, angle D is 90 degree. And MD is a common side for these two triangles. So, two sides included angle of this triangle, two sides included angle of this triangle are equal. Therefore, CDM triangle is congruent to MDA triangle. I prove these two triangles are congruent. Then what is the corresponding parts? Two sides. This is equal to this and this is common side. What is the third side? CM. Here third side is AM. So CM and AM both are equal. CM equals to AM by using the simplicity. CM equals to AM, but AM is what? Is half of the AB. Therefore, I can say CM and AM is equal to half of AB. So this is what I need to prove. Thank you, students.